Yeah, thank you. Thank you so much for joining this lesson. Remember to subscribe. Remember to share so that you may invite your friends to our great lessons. So we're going to present mathematics paper 2 section 2. You most welcome. Yeah, our sessions are fee based. The first question is on rates of work and proportions. So that is what we shall be discussing in the next few hours. It's a full paper, so we shall discuss all the questions in the section 2. Ladies and gentlemen, I would like to also welcome you to our powerful programs here for the December and November holiday. Yeah, secondary school students have their timetable, which is very parallel from the junior school timetable. We are offering mathematics, the sciences, and also the languages. So please find time and partner with Shifting Grades Online School. Please remember that our consultation line is already attached 0704153366. That is the number that you should reach out through for you to know more about our programs. The junior school timetable is also very parallel. The programs shall be parallel. JS will be learning as senior school is also learning their own substance. Welcome to our impactful, interactive, and transformative lessons. Remember also to invite a friend. This shall be happening purely online and via Google Meet. Let's get back now to the paper. Let's get to the paper. Guys, remember to subscribe. You can also comment. Let's know where you're catching us live from. Let's know whether you are hearing from us. Let's know whether you are learning something from Shifting Grades Online School. Otherwise, feel much appreciated. Can we get to number 17, which is our first question in this section? A tank has one inlet tap, A, and two outlet taps, B and C. When the tank is empty and both outlet taps are closed, the tank can be filled by tap A in 2 hours. When full and tap A is closed, the tank can be emptied by tap B alone in 8 hours or by tap C alone in 6 hours. Look at part A of this question. If the tank is empty at 7:30 a.m., find the time the tank will be full if part 1, tap B is closed and taps A and C are opened at 7:30 a.m. At the same time, we open tap A and C, whereby tap A is inlet, tap C is one of the outlets. One thing you're supposed to know is that when you are given the time taken for a certain event to occur, the working rate can also be obtained. And this is how we approach such a question. We usually say that if, for example, if A is filling this tank in 2 hours, then it is evident that the working rate of A per hour is half because it takes 2 hours. Then it means per hour it fills half. That is why it requires 2 hours to completely fill. Then the other tap, which is also opened at the same time, is C. Tap C is taking 6 hours to empty. That means the working rate of tap C is going to be 1/6. So it fills 1/6 in an hour. And that is why it shall require exactly 6 hours to completely fill. In case I tell you that there is some work that you usually take 3 hours to complete, it means you are working a third in every hour so that you may take 3 hours to completely fill. If you're working for 4 hours, then it means you're working a quarter of the work per hour. So when we say that tap A takes 2 hours, then it means it's working half an hour. Rate of A is half an hour. So when we have both A and B, both A and B opened, it means we shall have half and negative a sixth, because this particular tap is emptying the tank. Therefore, when we take half and we subtract a sixth, ladies and gentlemen, we are getting a third. So the absolute fraction that will be filled in exactly 1 hour shall be a third. Reason being, tap A is filling half as tap B is emptying a sixth. This is a question on rates of work, and I want to simply show you how this is very simple. You don't have to think that rates of work is a difficult concept or anything. This is a very simple work. Please remember to comment. Let's know where you're watching us from. Let's know whether you're getting us clearly from wherever you are. Looking now at the continuation of this question, we are saying that in 1 hour, when both A and B are functioning, they shall fill absolutely a third, because we add A filling half, and now B is emptying a sixth, meaning that we subtract for us to get the absolute fraction that is going to be filled within an hour. So in 1 hour, we fill one proportion out of 3 proportions. In 1 hour, we are filling 1 out of 3 proportions. What about the 3 proportions? How long shall they take? It is 3 times 1 out of 1, giving us 3 hours. So when both A and C are working, they shall take 3 hours to completely fill the tank. Now we get back to the question. The question is, find the time the tank would be full. You know, that was from 7:30 a.m. And now 3 hours later, we are filling the tank. When you add, you shall get 30 the same day. It depends on how you express your time. Of the question, all the 3 tabs are opened at 7:30 a.m. Okay, when you open the 3, look at this. We shall have now the working rate of B. The working rate of B, this was C, sorry. Working rate of B shall be, you know, B takes 8 hours to empty. So it's a if, meaning that A, B, and C, all of them working now, shall take A filling half, B emptying a eighth, C emptying a sixth. So absolutely, what fraction of this tank shall be containing water? Half, we subtract a eighth, we further subtract a sixth. This shall be 5 out of 24. 5 out of 24 in 1 hour. 5 out of 24 in 1 hour. That means in 1 hour, the 3 taps are filling. In 1 hour, they are filling 5 proportions. What about the 24 proportions? Because it's 5 out of 24. What about the 24 proportions? How long shall they take to be filled? So it shall be 24 by 1/5. Now, when we take 24/5, ladies and gentlemen, this shall be 4 hours. So 4 hours and 48 minutes. 4 hours, 48 minutes, meaning that the exact time of the day, shall be, we take 7:30 and we are adding 4 hours, 48 minutes. You see, on the minute side, we shall be having 78, meaning that we need part B. Let's look at part B. Yeah, let's check part B of this. We are told that the tank was empty again the following day at 7:30 a.m. Tap A was opened at 7:30 a.m. Tap B at 7:50 a.m. and tap C at 8:30 a.m. Find part 1, the percentage of the tank that would be empty, or that would be without water at 8:30. This one is supposed to again work it out very keenly. We know that by 7, the tank was empty, but now tap A got opened. Then it worked for 20 minutes. Is that 20 minutes? Yeah, up to 7:50 a.m. So can we say this? By 8:30, tap A has worked for an hour. Tap A has worked for an hour. That means tap A, according to its rate, tap A has filled half. What about by 8:30, tap B? Check this interpretation of the question. By 8:30, tap B, you remember tap B was opened at 7:50, which means it has worked for 10 minutes plus 30. We get 40 minutes. So tab B has worked for 40 minutes. And you see, 40 minutes equals to 40 over 60, which is 2/3 of an hour. 2/3 of an hour. Therefore, this tap is going to empty a eighth. Tab B is going to empty a eighth in 1 hour. So if it empties a eighth in 1 hour and it works for 2/3 hours, then how much will it have emptied? From 7:50 to 8:30, 2/3 of an hour. This will be 2 over 24, which is 1 over 12. So it shall have emptied 1 over 12. This tap will have emptied 1 over 12. What about tap C? Tap C is emptying a sixth because it takes 6 hours. Tap C. Okay, tap C is being opened at 8:30, so it has not yet worked. 0 fraction will have worked on 0 fraction. Yeah, thank you guys for joining. Thank you for joining. I hope we are together in that conclusion that tap C, which is being opened exactly at 8:30, has not worked any fraction. Therefore, we have now to talk about A, that filled half because it had worked for an hour, and B has emptied 1 out of 12 because it has worked for 2 hours up to 8:30 from the time it got opened. So now, when we subtract this, we discover that absolutely 5 out of 12 of the tank has been filled. So the part that is empty now empty part shall be 5 out of 12. 5 proportions out of 12 has been filled, which means the proportions that are still empty are 7 over 12 of the tank. If 5 out of 12 proportions have been filled, then we simply need to take 12 minus, we simply need to take 12 minus 5. Total proportions minus the filled proportions, so that we know the proportions that have not been completely filled. Remember, our consultation line is 07 04 15 33 66. That is the line you're supposed to be reaching out through to our programs. Thank you for joining us. Just remember to be a subscribed member of Shifting Grades Online School. This is a great institution. We are hosting the whole country, junior school and the secondary schools, for this powerful program from the 10th of November to the 12th of December 2025. So kindly find time and reach out to us so that you may know much about our programs, so that you may know how to enroll. The programs are parallel. We will have the secondary school continuing at its own time and the junior school continuing at their own time. So reach out through our 153366 so that you may know much about these programs. You are all invited. We talk about the second question now. This is a very wonderful question. When you follow keenly what I'm presenting, guys, you are really going to benefit. Look at Roman 2, guys. Now, the time the tank will be filled up. When is the tank going to be full? You know, we are talking about now. Okay. 7 out of, thank you for the comment. Actually, not the fraction without water. 7, if we just multiplying it by 100. So gives us 58. So we are talking about 58 and a third percent. 58 and a third percent, or 58.33. Thank you for that, for being very keen. Now we find the time the tank will be filled. Now, when this fraction of 7 over 12 has remained, the 3 tanks now start working. The 3 tanks. And remember, their rate is already captured in part A. When the 3 are working, in 1 hour, they fill 5 over 24. In 1 hour, they are filling 5 out of 24. Let me write that one keenly. What about this remaining fraction of 7 over 12? How long shall it take to be completely filled? So we talk about 7, we cross multiply over 12 times 1 divided by 5 over 24, which means times 24 over 5. So this now the time that will be taken to fill the tank. 7 over 12 times 1 out of 7 over 12 times 1 divided by 5 over 24. That is now why I'm taking the reciprocal, the inverse. So 7 multiplied by 24 out of 12 by 5. You know, this will take us to exactly 2.8 hours. 2 hours and 0.8 means what? 48 minutes. 2 hours, 48 minutes. Now remember the time they started working, the 3 of them, it was already 8:30, and now we are having 2 hours, 48 minutes. meaning that when we add, we are already having the 24-hour clock system. It can be in the 12-hour clock system, but basically that is how you're supposed to work out such a very good question. So this is a very involving question. It requires a student to be having the right knowledge on what we call rates and proportions. Question is on geometry and LOCI, number 18. Rates and proportions. Question is on geometry and LOCI, number 18. Okay, we work out 18. We work out number 18. Okay, using a ruler and a pair of compasses only for constructions in this question. Construct triangle ABC such that AB is the same as AC and is the same as 5.4 centimeters, and the angle ABC equals to 30 degrees. Measure the length of BC. Let's work on this triangle. Let's work on this triangle. The first thing that we're doing is to construct AB and also AC. So you do a straight line. You mark off part A. Then you use your ruler to measure 5.4. 5.4. That is B. Then while at B, you are supposed to construct while at point B. While at point B, you are supposed to talk about 30 degrees. Yeah, 30 degrees. Meaning that we construct 30 degrees without using a protractor. So that means we supposed first to stand at B. Let me show you the construction of 30 degrees. You stand at B, you make an arc. Then standing on the arc, you mark the same arc on the upper side and you produce the angle. This is now the construction of 60 degrees. Now, when you bisect 60 degrees, you shall now get the intended 30. So we stand on those marks now. At this point, we make an arc. Standing on the other one, we also make an arc. Then we join now that intersection of the arc, whereby we will have bisected the angle to point B. When you join to point B, you will now have constructed an angle of 30. So 30 is constructed by the bisection of 60. That is constructed by the bisection of 60. Then you are supposed also to stand at point A using the arc length of 5.4. You make an arc. You make an arc along that line, 5.4. Now when you use 5.4, when you use 5.4, C. Remember, this is also 5. as we talked about it. 5.4, 5.4. Confirm to be getting us clearly from wherever you are. Are you getting us clear? And by the way, have you subscribed to Shifting Grades Online School? So we are already having the triangle. Then the examiner is further advising us. The examiner is further advising us to now measure the length of AC. So let's get to the length of AC and look at the measurement. The length of AC, and look at that particular measurement. The length of BC, yeah, it's BC that is not measured. We are going to measure it accurately. We are going to measure accurately. Remember to stand at point B and extend your line to point C. Then you look at that measurement. Actually, it's exactly 9.2. So the length of BC, 9.2 centimeters. Yeah, that is the accurate length. 9.2 centimeters. Please confirm whether you are getting the same from that particular end. Confirm 9.2. Good. Can we proceed? Now, on the diagram above, in part B, a point P is always inside the on the same side of BCSA. Draw the locus of P such that angle BAC is twice BPC. Angle BAC. You know, we even don't know the length of BAC. This one, we've not even measured. This one is not even measured. But for us to come up with an angle, which is twice this one, or which is half this one, because now we need BP to be half, because BAC is twice BPC. Then it means if BSC is twice BPC, it automatically translates that BPC equals to half BSC. All right. So with that understanding now, then we need to apply what you call angle properties of circles. With angle properties of circles understanding, then we are supposed to use BC as a center. We're supposed to use A as a center and BC as a chord. Then we construct a circle. We construct a segment. So we are using A as a center. A is being used as center. So when you use BC to produce any angle along this, that becomes our P now. That becomes our P. When you project an angle from BC to P, you shall have the angle being half the angle at A. according to angle properties of circles. Yeah, according to angle properties of circles. Drop a perpendicular from point A to BC at D and measure AD. Dropping a perpendicular from point A to D. So what are we supposed to do at this point? You're supposed to stand at A. You stand at A and you make an arc on BC. Then standing on those arcs, standing at this point, you make an arc. Standing at this point, you make another arc. Then you now join. That will be a perpendicular. That is a perpendicular dropped from point A to BC. A perpendicular dropped from point A to BC. That's a perpendicular dropped from point A to BC. Now, the other thing is to measure. You know, we are told it's supposed to meet it. We are supposed now to measure the length. We measure the length. So I'm getting 2.8. Yeah, I'm getting 2.8. I'm getting 2.8. I'm getting exactly 2.8. So from A to D, guys, from A to D is 2.8 centimeters. 2.8 centimeters. So we are done with the dropping of a perpendicular. Yeah, the dropping of a perpendicular. We are done with that part. So we check the next. We check the next question. Part D. Determine and shed the locus Q on the same side of BC as A, such that the area of triangle BQC is 9.4. BQC is 9.4. These are basics of LOCI, ladies and gentlemen. These are just the basics of LOCI. These are the basics of LOCI. So we're supposed to know that there is a triangle BQC such that, because BQ is known, the length is found already as 9.2. When we multiply it by half times a known height, we now supposed to get 9.2. 9.4 area. Area is 9.4. So what shall be this height? What shall be this height? So we take 9.4 times 2 over 9.2. This is giving us 2.04. And actually in our drawing, we can't even go beyond 1 dp. So 2.0 centimeters is even okay. So let's check 2.0 centimeters. So we need to recognize that there is a parallel line from BQ, a parallel line to BC, which is 2.0 centimeters away. Same side as A. Same side as A. Those are basics, ladies and gentlemen. We are supposed to be able to know, if I tell you that there is a point where from BC, we need an area BQC to be 9.4, then that's a parallel line to BC. Q is on a parallel line. Q is a point on a parallel line. Q is a point on a parallel line. A parallel line to BC, and that parallel line is 2 centimeters away. So 2 centimeters away, 2 centimeters away, because we are already having a perpendicular line, we need to talk about exactly 2 centimeters away. Exactly 2 centimeters away, and reproduce the parallel line. And reproduce the parallel line. Let me show you the parallel line. Yeah, so this is the locus of Q now. That is the locus of Q. 2 centimeters away of BC. If you project a triangle using base BC to the locus Q, that triangle will be having area equal to 9.4, according to the calculation that we did at this point. That's a very good question, very involving, very engaging. Those who are joining us late, allow me to remind you of our schedule here. All the levels. High school timetable is independent. Junior school timetable, very independent. And you are all welcome. The program shall be totally online via Google Meet. No physical meetings. You get full interaction from the comfort of your home. So please try shifting grids for your own advantage. Please try shifting grids. Are we looking at number 19, all of us? A question on probability. We are told that a bag contains 5 red balls, 3 blue balls, and 4 yellow balls. Clement mixed the balls carefully, selected one ball, and put it aside, then picked another one and noted their colors. Draw a tree diagram to illustrate his pickings. This is picking without replacement, because he selected the first ball and put it aside. We are told that he put it aside. Intentionally, he put it aside. So we are talking about picking, picking without replacement. Picking without replacement. Thank you for following. I can see you guys are really following up. So let's come up with this particular tree diagram. Let's come up with this particular tree diagram. Remember, we are supposed to start with 3 branches. 3 branches because we have how many options? We can pick red, we can pick a blue, we can pick a yellow. So those are 3 possible options. Then alongside the branches now, we list the probabilities. Picking red is 5 out of, the total is 12, right? Yeah. So 5 over 12. Picking a blue one is 3 out of 12. And picking a yellow one is 4 out of 12. 4 out of 12. So those are the possibilities alongside the branches. Can we talk about now the second picking? Remember, after picking once, Clement put them aside. He put them. Let's look at the second picking. Confirm whether the screen is available on that side. Are you able to see the screen? Please confirm whether the screen is visible. Okay. So now, once Clement picked a red, now picking red again, because he didn't replace, the probability shoots down to 4 out of a new total of 11. Meaning that the others is 3/11, and this one is 4/11. Then after picking a blue one, we have the same possibilities: red, blue, and yellow. Picking blue for a second time, probability should be now 2 because it was 3, 2/11, but red remains 5/11, and yellow remains 4/11. And finally, after picking yellow, you can pick yellow again, blue, or red. Picking yellow again should be 3/11 instead of 4 now, and the other totals remain. So this total shall remain for red 5/11, and for blue 3/11. 3/11. Maybe I'm squeezing them so much, but at least from the explanation, you can get what we are pronouncing from this end. After now the possibilities like that, can we list all of them at the end of the branches? We have red, red, then red, blue, then red, yellow at that point. After that, you can talk about blue, red, and then we are having blue followed by blue. Then there is blue, yellow. Then there is yellow, red, yellow, blue, and finally 2 yellows, yellow and yellow. Yes. From this point now, from this particular point, let's all talk about the second part now. Once we have come up with the tree diagram, we can now respond to other questions. Then the other questions now go. Calculate the probability that both balls picked were red. So probability red, red. That's what you need. So from the first branch, we can see probability red, red, which is 5/12 times 4/11. What shall this give us? Is it 5/33? Yeah, 5/33. A very good question. Look at part 2 of B. Both balls picked were of the same color. Same color means probability picking 2 reds or probability picking 2 blues or probability picking 2 yellows. That is the meaning of same color. It can be any of these options. So picking 2 reds has already been covered. That is 5/33. You don't need to work it out again. 5/33 followed by blue. Then now we work out the totals now. Substitution, 5 over 33 times 2 over 11, and also the other case, which is 4 over 12 by 3 over 11. This is giving me 19 over 66. (19 out of 66). That is the answer according to me. Please confirm whether you're getting the same. Just confirm whether these are the answers that you're getting. Yeah, I can see the working is very clear from that side. Let's comment. Let's be active in the lesson. Let's be active in the lesson. This is Form 3 work. And Form 3s are invited. Upcoming Form 3s are also welcome to the broadcast. Don't be left out just because you're a Form 2. Remember, the last time you were also last time you were a Form 2, but now you are waiting to join Form 3. So you are most invited. Don't be threatened by anyone or anything. You are equal to the task. So please join us with all the confidence and feel much invited to Shifting Grades Online School. Remember to subscribe. Remember to subscribe. This is your home of academics. This is your home of academics. So let nothing threaten you. Now, there was no red ball from the 2 balls picked. Probability no red, in other words. Probability no red. We just need the options which have no red. Probability no red means either, let me change the color here, either BB, no red, no red, no red. So probability no red, it means probability BB, that is a blue, or probability. Another option of no red is by, another option of no red is probability. Okay, I can use or, then after substituting, I'll be adding now. Probability, when we talk about no red, any R, that's our point of interest. That's our point of interest, which is a probability yellow. Those are the options without any red. Probability no red. So BB means 3 over 12 times 2 over 11, or means addition. Then again blue, followed by yellow, 4 over 11, or yellow, followed by blue, 3 over 11, or finally yellow, followed by yellow. These are now the options that have no red. Probability no red. Probability no red. 3 out of 12, 2 over 11, plus 3 over 12, 4 over 11, or, which means addition, 4 over 12 multiplied by 3 over 11, Or finally, 4 over 12 multiplied by 3. Why is 4 over 11 and 3 over... Yeah, should be so. It should be so. Over 11. It should be so. 7 out of 22. That is now the final answer. That is the final answer. Number 20, ladies and gentlemen. This is a question on cubic functions and cubic curves. Cubic functions and cubic curves. Complete the table below for the equation y equals to x power 3 minus 2x power 2 minus 4x plus 7. So when we are told to complete the table, remember some values have already been fed into the table. So we need now to use substitution skills. Substitution skills. So whenever you are substituting x, I would encourage people to open brackets. For example, when substituting -2, this is what you shall type in your calculator. You open brackets, -2, minus 2, then in the calculator. That is what you're supposed to type in the calculator. I open brackets -2, I raise it to power 3. Then -2. I open brackets, -2, I square it. Then I open brackets after -4, I feed -2, and I add 7. I'm getting -1. This is supposed to be 0 according to the intervals. And when you substitute 0, you confirm that it is so. Then at 2, I'm supposed to write 2 power 3 minus 2. I open brackets, 2 power 3, 2 power 2 now, sorry. Then -4, I open brackets for 2. Then I add 7. I'm getting -1 once again. Then at 4, I write 4 power 3. I open brackets for 4 squared. Minus 4, I open brackets for 4. Then this is giving me 23. Yeah, that's 23. This is 23. So you can see the values of y are ranging from -26 all the way to +23. You see those values? They should guide you now to coming up with a very good scale. A very good scale. Okay. Using the scale 1 centimeter to represent 1 unit, that is on the x-axis, and 1 centimeter to represent 5 units on the y-axis. Draw the graph of the function. This is already very guiding. The question is very fair because already a scale for us has been chosen. A scale for us has been chosen. So let me have the y-axis at this point. It's 0, 1, 2, 3, 4, 5, 6, 7, -1, negative. Those are enough intervals. Those ones are, this is the 5, 10, 15, 20. Let me check. This should lead us to choose a different graph. I think they limited the domain so much. So allow me use this one for the same question kindly. Allow me use a graph question, then we shall clear it when we reach this question. Please allow me adjust. The domain provided is very limited. So you will allow me now adjust to this point. Yeah, allow me now work with this one. I hope we are together in that particular agreement. So we label now the axis 0, 1, 2, 3, 4, 5. Then intervals of 5, 10, 15, 20, 25. That's already okay because we need a maximum of 23. On the negatives, you can have -5, -10, -15, -20, -25, -30. This is very okay. All the domains have been, we needed up to -26, -5, like that. Now this one, we are able now to thank you guys. I can see your comments. Somebody says I'm a product of shifting grades. I do appreciate Mwalimu. Gerisa, hi. Thank you all for being around. Thank you even for the backbenchers who are not commenting. I really appreciate all the followers. So now we plot now. We plot. So the coordinates are following one another now from -6, -1, 8, -26, -26 according to the table, -26, -1, 8. Or let me take a photo of this so that I don't waste a lot of time scrolling back. Okay. So with this now, at least I know what we are plotting now. What are we plotting? -26 against -3. -26 is just below -25. At -2, we have -1. It's -2, we have -1. So the coordinate shall be here. At -1, we have +8. At -1, +8. At 0, we have 7. At 0, we have 7. At +1, we have 2. At 2, we have -1. At 2, we have -1. At 3, we have 8. We talk about the curve. When is done, can we establish a curve? Yes, we can do. So let's do a curve. You can see already the dots are suggesting a straight line. The dots are already suggesting a straight line. You join them smoothly. Now, if it's about a smooth curve, that one, I've done it perfectly. So this is a smooth curve, a very smooth curve, ladies and gentlemen, a very smooth curve. Please comment on the curve. Please comment on the curve. Then after the curve, now we check the questions thereafter. After this curve, what else are we doing? After plotting the curve, that is now part, that was part B. Part B is done. When we proceed to part C, what are we supposed to do? Use your graph to estimate. Use your graph to estimate the equation or the roots of the equation x power 3 minus 2x power 2 minus 4x plus 2 equals to 0. So what you're supposed to do here, the equation that was plotted from the equation that is supposed to be solved using the same graph. So y equals to y equals to x power 3 minus 2 x power 2 minus 4x being solved now. X power 3 minus 2x squared minus 4x plus 2. When we subtract corresponding terms, what are we getting here? What are we getting here? What are we getting here? What we are getting is y equals to x power 3 cancels, negative 2x power 3 also cancels, This one also cancels, and we get positive 5. 7 minus 2, which is 5. So we need y equals to 5. So now we draw the line. Draw the line y equals to 5. When you draw the line y equals to 5 on the same axis, y equals to 5 on the same axis, you know y equals to 5 is the coordinate at this point. Y equals to 5. We just do the line y equals to 5. That is y equals to 5. Now with the line y equals to 5, you check where the curve cuts the x-axis. Okay, where the curve and the line meet, then you read values of x there. So I can see one of the points is here and the other point is here. So the points are negative 1.4, negative 1.4, and also 0.4. Negative 1.4 and 0.4. Negative 1.4 and 0.4. So now look at those values. Just look at those values. You're supposed to read them carefully like that. Are we checking the second question? Remember, when you look at part B very carefully, you discover that there is a repetition here. We have already done that part. So let's go now to Roman 2, that whereby we are supposed to repeat the same. We write the original equation, y x power 3 minus 2 x power 2 minus 4x plus 7. Then we subtract 0 equals to x power 3 minus 2x squared minus 3x plus 3, and we subtract. Yeah, and we subtract. So when we subtract all this, again, we are subtracting corresponding terms. So this becomes y equals to, because y minus 0 is y. X squared, x power 3 minus x power 3 becomes 0. This also becomes 0. Then minus 4 minus negative 3. It becomes minus 4 plus 3, which is just negative x. Then plus 7 minus 3, which is 4. So this is the line that we are going to plot. To plot this line, you come up with a small table of values, x and y values. 3 values are usually enough. So you can even start at 0, 1, 2. When x is 0, y shall be 4. You just substitute 0 in that equation. And from the look of things, y equals to 0 plus 4, which is just 4. Then when we substitute 1, we shall get y as 3 because of negative 1 plus 4. Then negative 2 plus 4, which is a 2. So these are the coordinates that we are supposed to plot, ladies and gentlemen, for that particular question. So to plot these 0, 4, 1, 3. So we can now see the line has perfectly been drawn. The line is perfectly drawn, meaning that with the straight line, we can now find the roots. We can now find the roots of the equation. Yeah, we can find the roots of the equation. So we check where the curve and the line are meeting, and you can see the first point of intersection is still at negative 1.4. With this point, negative 1.4, and another point is here, 2.4. Negative 1.4 and 2.4. So x equals to negative 1.4, x equals to 2.4. 1.4, 2.4. Like that. So that's it. That's it. Can we check 21 now, which is a question on vectors, vector 2 actually, paper 2 mathematics. In the figure below, M and N are points on OB and BA respectively, such that O to M, M to B equals to 2:3. Let me interpret the ratios instantly instead of later, 2:3. Then we also told that BN, B to N, N to A is 2:1. 2:1. That is what it means. I'm just placing the ratios immediately. Now, ON and AM are intersecting at X, as we can see. Then now goes the question here. Given that vector OA is A and vector OB is B, expressed in terms of A and B, the vectors AM, vectors AM. Let's look at vector AM. Now, vector AM means vector AM, let's show you, we identify a route from A to M. So we can talk of AO plus O to M. So what is the vector O to A to O? That means the reverse of A. The reverse of A, because OA is vector A. Then it means AO is the reverse, which means minus now. And then when we talk about vector OM, it means 2 proportions out of the 5 divisions of vector OB, which is vector B. Remember, that's already correct, but can still be rearranged to be 2 out of 5 vector B minus the vector A. Very simple. Very simple. Very simple. I hope you are following keenly. Guys, I hope you are following is very keenly. And I hope you guys are still learning something. It's my hope that you guys are learning something. Vector AB is also supposed to be determined. Vector AB is the next to be determined. So vector AB, again, we identify a route that will help us move from A to B. Vector AB means AO, then OB. AO rearranged to give us a more precise answer. as vector B minus vector A, vector B minus vector A. You see that? I know so far we are doing very well. I know so far nobody is getting any challenge in following through. But let's take a step now to ON. Vector ON means, we can use several routes. From O to N, according to the straight line there, we can follow OB, then BN, or OA, then AN. So let's talk about vector ON as O to A, O to A, then A to N, meaning that we have vector A plus, what is O to N? AN. What is AN? AN is 1 out of the 3 proportions of AB. 1 over 3 vector AB. And vector AB has already been determined. So we need A plus a third, A plus a third, vector AB, which is B, minus A. This gives us A plus a third B minus a third A after opening of the brackets. A minus a third becomes 2/3 vector A plus a third vector B. This is interesting. This is interesting. Now all the vectors have been expressed. All the vectors have been expressed, and I've also tried to interpret the ratios that had been provided. We are told in B that by taking OX as H or N and AX as K, AM, where H and K are scalars or other constants, find two expressions of OX in terms of A and B, hence determine the constants H and K. A very good question, which just requires your patience, and I also need you to follow through very carefully. When you talk about OX in 2 different ways, the first OX has already been stated by the question. OX equals to a scalar H multiplied by ON, and ON has already been talked about up there. 2/3 A plus a third vector B. So with this, we can simplify more and have 2/3 H vector A plus a third H vector B. Then can we express another OX? We can express the same OX, but now using a different root. And this second root should accommodate AX. The second root for OX should accommodate the second expressed vector here, AX. So we need to go to OX, but through AX. So to go to OX through AX, it means OA, then AX. OA, AX. OA, AX. At this now, can we agree that this is vector A plus AX? AX has been given by the examiner as K, vector AM. AM has already been talked about here. AM is already here. 2 over 5B minus A. 2 out of 5B minus A. That way. When we start opening brackets, brackets here. We shall now talk about vector A plus, confirm that. Please confirm that. Okay. Yeah, that is it. So with this now, with this, can we group some terms like the vectors with A together? A minus Ka plus 2 out of 5 K vector B. So that A can be factored out. Vector A can be factored out. This is still an expression of OX. That is still an expression of OX. We are already having an expression of the first OX here. So we have one expression of OX. We have a second expression of OX, like that. With two expressions of OX, ladies and gentlemen, with two expressions of OX, with two expressions of OX, we can now find the constants by equating the coefficients of every vector. The coefficients of vector A from the first expression should be equated to the coefficients of vector B. Coefficients of vector A and coefficients of vector A in the second expression. So from the first expression, the coefficients of vector A are 2, that's H, should be equal to coefficients of A in the second, which is 1 minus K. We get one equation, a Roman 1. Then we also get another equation by equating the coefficients of B. Coefficients of B in the first expression is a third H equals to coefficients of vector B in the second. Coefficients of vector B in the second is 2 out of 5K. Roman 2, like that. So now when we solve these two simultaneously, guys, we shall get the H and K simultaneously. So from equation 1, okay, from equation 2, from equation 2, the value of 5, 6 out of 5 in equation 1. This is what we ought to substitute in equation 1. So at that point now, we can rewrite equation 1 as 2 out of 3. Instead of H, 6 over 5K equals to 1 minus K. So we can now group terms together, ladies and gentlemen. This is already 4 over 5K, 4 out of 5K, confirm. Yeah, by 3, 1 by 3, 2. So 4 out of 5K equals to 1 minus K. Meaning that the value of K shall be, we have 1 and 4 over 5K. 1 and 4 out of 5K after grouping terms equals to 1. Meaning that the value of K shall be, you divide it through And it's good for you to know that this is 9 over 5, meaning we have 5 out of 9 as the value of k. If that is the value of k, ladies and gentlemen, why don't we get the value of h? Why don't we get the value of h? So h is going to be 6 over 5, the value of k. 6 over 5, the value of k. So 5 will cancel out, and by 6 we'll get, by 3 we'll get 2, and by 3 we'll get 3. So this is h. So we are having the value of h as 2/3, the value of k as 5 out of 9. Wow. Wow, wow. That's a very wonderful solution. Please make sure whenever you get a question like this one, you just follow through. You just follow through like that. You just follow through like that, and you will always find yourself at the right answers. Looking at part C now, ladies and gentlemen. Looking at part C of the question, the last 2 marks of this question. You know, you're supposed to maximize. You're supposed to maximize the scores. You're supposed to maximize the scores by ensuring that you score the 10 marks. So the ratio in which m divides ax, m divides ax. Let's look at the expression of ax together. K, am. K is already found. Am. Ax equals to 5 over 9 am. So line am with the straight line am, then x is somewhere at the mid. Let me check. X is somewhere at the mid, yeah? X is somewhere here. We are being told the length ax equals to 5 out of 9 of am. So am has been divided into 9 proportions, meaning that we have 4 proportions remaining here. So x divides am internally in the ratio of 5:4. But now m is dividing ax externally in the ratio from a to m, we are having 9. And from m back to x, we are having 4. So 9 is to -4. We are supposed to be able to understand the division of lines, proportional division of lines, external division of a line. And this one is 9 is to -4. So from a to m, 9, and back to x, 4. So we call it a negative like that. Can we check 22 now? Three-dimensional geometry. Three-dimensional geometry. Three-dimensional geometry. Mhm. So what we have is a diagram here. They want us to study it, to figure it out. We figure out the figure. The diagram below represents a wooden prism. ABCD is a rectangle. ABCD is a rectangle. Now points E and F are directly below C and B, respectively, perpendicular to the plane at the base. M is the midpoint of CD. AB equals to 8, as you can see. BC equals to 10. BC equals to 10, as you can see, well labeled. Then CE equals to 4.5, as you can see. Calculate. What are we calculating? The size of the ankle. Calculate the size of the ankle. Which ankle? C, D, C, D, E. So we supposed to do what you call translation. Because the length CD is not given, then we know that AB, when translated along this diagram, it shall become CD. That is called translation. So this is 8 centimeters or so. And we said this is perpendicular, so we expect a right angle at that point. Now, with that understanding, ladies and gentlemen, with that particular understanding, can we say that this angle now, CDE, it requires what we call cosine, because we need to identify a trigonometric ratio that will help us to find these particular angles and distances. So we open brackets, 4.5 divided by 8, close brackets, and you get your 34.23. Thirty-four point two three. 34.23. Huh. That's a very good question. A very good question. So as you are three-dimensional geometry, ladies and gentlemen, you are supposed to be very good in what we call trigonometry. That is the three basic laws, the three basic ratios. And apart from that, ladies and gentlemen, you're also supposed to be very conversant with what you call Pythagoras theorem. It helps us to find unknown distances and unknown angles. In part B, we have two parts. In the first part, ladies and gentlemen, in the last part, we are talking about the length of AC. The length of AC from A to C. How can we find the length from A to C? Now, when you treat, this is also 8. I'm talking about translation. We translate the length BC to a different line, and this length also becomes 10. So with 10 centimeters and 10 centimeters up there, or with 10 centimeters, then we are having 8. Remember, ABCD is a rectangle, meaning that it's right angled at this point. Right angled, and now we need the length A to C. The length A to C now, the length A to C will require Pythagoras theorem. So 10 squared plus 8 squared, the square root. 10 squared, 8 squared, the square root. Back to my calculator. 10 squared plus 8 squared, taking now the square root. This is 12.81 centimeters. 81 centimeters. 12.81 centimeters. Yeah. 12.81 centimeters. The next, we are finding the angle AC makes with the plane. AC is a line and ADEF is a plane. Allow me, ladies and gentlemen, to talk about now. Allow me to talk about the following: plane and angle. Remember, we've already gotten square root of 164. This one is root 164. That is the length there. With that length, and we're also having the perpendicular height CE, we can say that for us to get the angle between a line and a plane, we need the angle made by the line and its own projection on the same line. Therefore, the shadow of AC on the plane shall be AE. So we need this angle between a line and its own projection on the plane. That is what we need. So with the hypotenuse, and we are also having the perpendicular height, it seems that we shall need again what you call sine. So the sine of the angle unknown, you can call it alpha. The sine of alpha, ladies and gentlemen, shall be 4.5 opposite out of adjacent, the root of 164, or rather 12.81. So how shall we get alpha? The sine inverse of 4.5 out of the root of 164. This is going to be 20.57. 20.57. 20.57. From your calculator, very simple work. From your calculator. Without straining, without much ado, you just find the angle. Very simple work. Very, very simple work. Okay, let's look at part C. Find the length of MB. There is a MB, a length called MB, from M to B. From M to B. Let's check. From M, allow me first clear some space here. This point. Okay. Now, can we guys express something here? You know, we are already talking about MB, and there is one thing we've been assured, that M is the middle of CD, meaning that CD being equal to AB, this becomes 4 and this part becomes 4. And something again that you're supposed to notice here is that ABCD is a rectangle, meaning that this is right angled. So with 10 and 4 and a right angle, we can proceed with what you call Pythagoras theorem and talk about the hypotenuse now. So 10 squared plus 4 squared, the square root. 10 squared plus 4 squared, the square root. 10 squared plus 4 squared, the square root. 10.77. It's good to stick to an accuracy of 4 significant figures, more so when the question is open like this one. Nobody has told you to round off to the nearest whole number, so avoid premature rounding off. Don't make numbers the nearest whole number unless you've been instructed so by the examiner. Just ensure, please just ensure that you are having your answers to 4SF. As you can see, my answers, they are to 4 significant figures. Then finally, there is an angle somewhere to be found. There is a certain angle to be found. And which angle is that? The angle CBM. The angle CBM. Angle CBM. 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 So the angle at this point, CBM, we can apply even tangent. This angle can be beta. So tan beta equals to opposite over adjacent, tan beta. The tan of the angle at that point should be 4 out of 10. So that beta becomes the tan inverse of 4 over 10. This gives us beta as equal to shift tan 4 over 10, which is just 0.4. This is 21.80. 21.80 degrees. 21.80. 21.80, yeah. 21.80. Okay. That's a very good question. So you're not supposed to fear any topic. You're just supposed to particular question is doable. Now remember we used the space here for number 23 for a certain question. And that means we now come here, we clear up the space. We clear up the space so that number 23 can now be done. We clear the space for number 23 now. We had misused it. Now we clear it up for 23. Yes, so that you may check matrices and transformations. Matrices and transformations. You can't follow up with shifting grids and you fail. You cannot fail with shifting grids. That one is a sure bet. Followers of shifting grids always make it in mathematics and physics. So please make this one your best channel. Make it your only online school. Make it your only online school. Yeah, make it your only online school. So now this one, we'll be using this one for a different question now. Uh-huh. 0, 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5, -1, -2, -3, -4, -5, 3, 4, 5, 6, 7. Yeah, with this now we can start responding. Let me check whether we are still properly connected. Yeah, number 23. Now the vertices of a rectangle are given us, just as you can see on the grid provided. Draw the rectangle and its image, and a transformation whose matrix is -2, 0, 0, -2. We know very well that a matrix of transformation times the object should give us the image. With that relation clearly being able to remember, if a student is able to remember that, then they can maneuver through. Matrix, and it should be in that order. You pre-multiply, should be in that order. Then we have now coordinates of A is -1, -1. Coordinates of B, -4, -1. Coordinates of C, -4, -3. And coordinates of C, -1, -3. Then we carry out multiplication now. We perform multiplications in matrices. We know how this happens. We multiply all the first row by all the columns. So by the first column, that will give us -2 by -1 and 0 by -1. So that becomes +2. In the next, we multiply by the next column. -2 by -4, that becomes 8. 0 by -1, so this just becomes 8. -2 by -4 in the next column. -2 by -4, that's 8. 0 by 3, you just get the 8. Then finally, -2 by -1, we get +2. And the 0 by -3 just becomes a 0. That's where we are. That is where we are. Can we now talk about the second row, this one, by all the columns once again? So by the first column, it should be 0, 0 by -1, and -2 by -1, making it +2. 0 by -4 and -2 by -1, making it +2. 0 by -4 and -2 by -3. 0 by -1 and -, making it +6. So we have the coordinates now. We had not been told by anyone to state the coordinates. Actually, that's A. -1, -1. What am I plotting, guys? That's 1, 1. So we need, it has actually been a while to your attention. Yes. This is the graph. This is the graph that we're plotting now. This is the Cartesian plane where we shall be plotting. So we need coordinate -1, -1, -1, -1, -4, -1. That's B. This is A. That's C. We have D now as -1, -3. This is D. So now we got the triangle already displayed. We have the triangle already displayed. We just connect all the edges of the rectangle, not triangle. So here is the rectangle. that way. Then this particular rectangle, the image 2 2, that's A prime. Then we have 2 8. Okay, 2 8. What I can see is that we really needed the 8th division on the vertical axis. Sorry for that. So 2 8 should be somewhere here, because I don't want to start afresh. But remember, you should manage your scale very well. 6 8. So we can now join. Its image, triangle, and its image. Then after that, now we have another triangle, another rectangle here, which is the image of the first image under transformation. The matrix is given there. Determine the coordinates first. Then you also draw. Determine the coordinates, and we again draw. So we need to multiply the matrix which is half 1 1 half. We multiply by the first image, which is having coordinates at 2 2. Coordinates at 2 8. Then coordinates at 6 8. And also coordinates at 'Did I really plot the right thing? Okay. Look at it this way. You know, we are having coordinate 8 2. Actually, I think I was straining unnecessarily there. We were to start at 2 2. 2. So 8 2 is a coordinate here. This is where B is supposed to be. That is it. It is actually not what you thought. So the domain is really occupying vertices fitting properly chosen. That's how that is how the first was supposed to be. 8 2, 8 6, then 2 6. Is it 2 6? Confirm. Yes, 2 6. Now we multiply now. As usual, row times column. So half by 2, that's 1, and 1 by 2, that's 2. So 1 plus 2, we get 3. Next should be the same row in the next column. Half by 8. You know, half by 8 is giving us 4. Then 1 by 2, 2. So 4 plus 2, 6. Half by 8, 4. 1 by 6, 6. So we get 10. Because of 4 and 6, yeah? Half by 2, we get 1. And 1 by 6, we get 6. So 1 plus 6, we get 7. Multiplication of matrices. Form 3 work now being applied in Form 4. The next one, row times the same columns. 1 times 1, 1 times 2, and half times 2. So that's 2 plus 1, we get 3. 1 times 8 and half times 2, we get 8 plus 1, 9. What about 1 by 8 and a half by 6? That's 8 plus 3. 8 plus 3 shall give us 11. What about when we talk of 1 times 2 and a half by 6? That's 2 plus 3. So that is it. So we are supposed to write coordinates here now. 3, 3. The question here is on coordinates. 11. Like that. So this is just a contralateral, which is not necessarily a rectangle like the others, depending on the transformation that worked on it. Depending on the transformation that worked on it. But generally, those are the coordinates. Those are the coordinates. But do you see now we require a y coordinate with we might not really accommodate such a figure together with the first triangle. They may not be accommodated provided domain. They may not be accommodated. So what you need to know is that a rectangle can be that enlarged to a bigger rectangle, and you know that area equals to length times width. It can also be stretched. It can be stretched into a bigger rectangle under a stretch. Then under a shear, it can be twisted to what we call a parallelogram. A rectangle can be twisted into a parallelogram. And you know that with a parallelogram, area equals to base times perpendicular height. Base times perpendicular height. So what am I advising you to do? Please now find a graphical page which is going to accommodate this figure. It is likely to be a parallelogram after a certain shear to possess these particular coordinates. Then once you've come up with a parallelogram, now determine the base length and also the perpendicular height. You can even count the units according to the spaces it shall occupy. Just count the coordinates literally. For example, here we have 1, 2, 3. Just count literally the coordinates, the units it occupies, so that you may determine the units along the perpendicular height and also the base length. And with that, you'll be able to find the area. If it remains a rectangle, we know it's base times length, your base length times height, or other times width, depending on how you interpret the rectangle. So it's likely to be a parallelogram. So please apply your general knowledge on a suitable Cartesian plane. Number 24 now, ladies and gentlemen. Number 24. An aeroplane left town P, which is a 65 in the north, 15 in the east, to another town, which is a town Q, 65 in the north and 165 in the west, at a speed of 200 knots, using the shortest route. Taking pi as 22/7 and radius of the Earth as 6370 kilometers. Find in part A, Roman 1, the shortest distance traveled in nautical miles. Shortest distance in nautical miles. One thing you're supposed to understand, allow me to sketch this information, called supplementary longitudes. When you add the two, you are getting 160, an angle difference. And we usually say this, whenever you got two places on supplementary longitudes, it means this. When you use the poles, whereby it is along the poles, for example, the North Pole in this case, it is along the poles where we access the shortest distance through, not along the parallel latitude of 65. So when you move, this is a 0 degrees equator. Then now we are along 65 in the north. Yeah, 65 in the north. So when you move along 65 north, that one will be a long distance. But when you move, let's say we said this is 15 in the, not 16 in the east, this is the west, sorry. If this is 165 in the west, and you move along it this way, from Q to north, then you continue using the same route, you will find yourself automatically at P, which is on 15. Then you pass through the North Pole downwards to Q, you will be accessing the same place. The route remains. So you don't change your route. You don't change your route when you follow the great circle, as long as places are along longitudes. So now, along that great circle, from the equator again to that, along the great circle, we can find okay. So at this point, ladies and gentlemen, we can now check the angle at the arc of this great circle. 180 minus 65 and 65. So the angle is 50. So we have a great circle now for the arc PQ, a great circle whereby at the center we have 50. We need 180 minus 65 and 65. We get 50 degrees, like that. We get 50 like that. At this point now, we can talk about distance in nautical miles along a great circle. The formula remains: distance in nautical miles along a great circle should be 60 simply by beta. So 60 multiplied by 50 will give us 3,000 nautical miles. 3,000, yeah? 3,000 nautical miles. That's simple. 3,000 nautical miles. In part 2, the time taken from P to Q in hours. Time is usually given by the distance out of speed. A distance of 3,000 out of 100 knots. It means nautical miles per hour. Speed in knots means what? Nautical miles per hour. Can we check part B? Another plane left P at 1:30 p.m. local time and traveled to T. T is 65 north along the parallel of latitude. Find in Roman 1 the distance between P and Q to the nearest kilometer. So this is now along a parallel latitude, or rather distance along a small circle. Distance along a small circle. Moving from P, remember the position of P was 65, 15 in the east. And now we are moving to T, which is on the same latitude, but now 60 in the east. So we are going further to the east. We are going further to the east. So what is the angle difference? So we are using a circle of latitude like that. Then if we have to identify, the axis of the earth like that, we are moving from a point. Assume this is the circle 65 in the north, circle of a latitude. We are moving from already in the east, 15 degrees in the east, all the way to 60, in the east. Meaning that along this small circle, the angle at the center can be determined. From 15 to 60, we subtract so that we may know the angle there. 60 minus 15, is it 45? Yes. So we are moving in such a circle now. That is the arc length we are covering, this one. From P to T. From P to T like that. So the first thing we're supposed to remind ourselves is how to get distance. Distance, and this time round in kilometers. Remember, in kilometers along a small circle. So the distance should be given by out of 360. Two pi r. Yeah, cosine of the latitude, where the two places are. So this now gives us what? We proceed to substitution. 160 to pi r cosine of 65. You get the distance to the nearest kilometers, 45 by 2, or 45 over 360 by 2 by 22 over 7 times 6370, the cosine of 65. This gives us 2115. That is the distance in kilometers along the small circle. Then now we have an issue of time. We're also finding the local time of arrival. The local time of arrival at T if the plane flew at a speed of 470 kilometers per hour. Let's take first the time taken. Distance of a speed, a distance of 2115 divided by 470. This is 4.5 hours. 4 hours, 30 minutes. When you talk about 4.5 hours, It means 4 hours, 30 minutes. 4 hours, 30 minutes. Now with this, ladies and gentlemen, with these, we should be able now to finalize the time taken. One thing we're supposed to know that the plane left P at 1:30. Then it took 4 hours, 30 minutes. So let's check time taken. And also we consider time difference because the places are in 2 different longitudes. You know, we usually say 1 longitude difference. What about when the difference in longitudes is 45 difference? Yes, so we can look at the final part. We can look at the final part of this, whereby we are saying, let me just do a recap. We are saying that this plane took 4 hours, 30 minutes to travel. So apart from the time taken, we are also saying that the places being in 2 different longitudes, there is a time difference of 3 hours between T and place P. Therefore now, because it left at 1:30, we are supposed to add the 4 hours, 30 minutes taken to travel according to the speed. Then we proceed to add the time difference of 3 hours because of the different locations of the 2 places. With this, now we can talk about 30 plus 30, 60 minutes, which is just an hour. 0, 0, we carry the whole hour to the other side. So 1 plus 1, that's 2. 2 plus 4, 6. Plus 3, 9. So we'll have 9 p.m. the same day. 9 p.m. the same day. That is the time of arrival of the plane at place T. That is it. So the paper is really very good. I encourage you to walk through it slowly. You can even rewind. You can continue watching. You can share to invite people. Invite people also to our wonderful program here via Google Meet. Very interactive, transformative, impactful. Nobody can join our programs and end up regretting. So please join us and get the best. Also, junior school are invited to our serious programs. Through it's 07 0415 3366. That is the number you are supposed to reach out through.